Okay, good morning. So we continue the lesson. Let me start refreshing your memory a little bit about what we learned before. So if you remember, if I want to write an equation for the straight line, I have two alternatives, yes? One alternative is that you give me 1 point on the line and you give me the slope of the line. Then I should be able to write that equation, yes? So if I give you 1 point and the slope, the best approach is this 1 point formula that we derived yesterday. So we know why it should work. For the people who are interested to know things in more detail, but if you are just of that type of students who want to use, you are free to use that one. But the formula I wanted you to memorize, even though this is also given in the formula sheet, okay? So if I give you a point whose coordinates are given for you, say x node and y node, I give you these numbers. It's a point on the line, and I give you the k value explicitly, yes? And I ask you to write an equation for the line. That is called the 1 point formula, yes? So this is y minus y node equals to k value x minus x node. This is one standard way of doing that. So if I give you an example, write down an equation for the line. I always mean straight line in this chapter, okay? For the line whose slope is minus 5 and passes through the point let us call it point A, whose coordinates are minus 1 and minus 5. Let me make it minus 6. Okay, so this is a very, very standard problem. So when you want to write an equation for a straight line, one alternative is look for the slope and a point. If you can extract those informations in your problem, then you have that formula that you need to understand why this formula is working. I talked about that yesterday, but now we just use it. Okay? So how should I solve the problem? Simple, yes? I would say that, okay, by reading the text, I realized that the slope, the k value, is directly given to be minus 5. And this is the point on the line. So the x coordinate of this point can play the role of the x node, and the y coordinate of this point can play the role of the y node. And everything that I need by reading the text, I understand and plug it back into that formula, I am done. But of course, you have to simplify it a little bit. So I would write y minus y node is equal to k x minus x node. I simplify that, y plus 6, I have minus 5, and then x minus minus 1 is x plus 1. And then I multiply minus 5 in, it becomes minus 5x minus 5. I move 6 to the other side, it becomes minus 5x. Minus 5 minus 6 is minus 11. So then I will stop here. So this is an equation. You see, I always use an equation because if some of you multiply it by 2 or divide it by 3, that would be a different equation, but it will represent exactly the same line. So that's why we always use an equation. But I do not use a line, I use the line because that is unique. a line that passes through this point and its slope is -5 is a unique line. So I have to use that. Okay, so that is one alternative. We also learned something more, and then I told you that it's always good to have this example in mind, but I want to give two types of these examples here. I want to ask your opinion about that. So I would say that write down an equation for the line that passes through the points I give you two parts, yes, through the points. Part 1, I give you A equals to -5 and 2, B is -3 and -1. Number 2, A, so let me make it 3 cases, yes? So let me write 1 and 3, B, 5 and 3. Number 3, A is 5 and 2, B is 5 and -7. So these two examples are very simple, but you need to know them because they will appear a lot of times here in this chapter. So let me just put a box here. Okay, so you see that the context is more or less the same. In this problem, I wanted to write an equation for a straight line. In this problem, I want to do the same thing. I want to write an equation for a straight line. But in this problem, one single point was given and the slope was given. But in this new problem, the slope is not given, but instead of having the slope, I have 2 points instead of having 1 point. Yes? So then you need to remind yourself about these formulas. Do you remember? So the k value is delta y over delta x. This is one way to define that. There was another way to define k, which was the definition. It was the tangent of the angle that my line makes with the positive x direction. But that notion of tangent is useless here because I do not know anything about the angle that my line is supposed to make with the positive x direction. Okay, and then what is the meaning of delta y? Do you remember? It means the change in y. So you can write it as y1 minus y2, x1 minus x2, or the other way around, y2 minus y1 divided by x2 minus x1. It doesn't matter. But if you start with the first one in the numerator, you have to start with the first one in the denominator as well, and the other way around. So this formula becomes important if you want to solve this problem. Because here in this problem, you don't know anything about k, you have to calculate it yourself. Okay, let me do it here now. So number 1. Here, it doesn't matter. You need to give names x1 and y1 to one of them, and x2 and y2 to the other one. It doesn't matter which one you want to do that. So let me take this one x1 in my head, and this one y1, and then I take this one to be x2 and y2, and let me, for example, use this middle formula. So you have a lot of freedoms here. You can choose this one to be x2 and y2, this one to be x1 and y1. It doesn't matter at the end. And you can use this formula instead. It doesn't matter. So the first thing that I have to calculate here is to write k value. So I will use the middle one. So you see y1 minus y2. What is y1? Is 2 minus y2 itself contains a negative sign. So don't get confused with the minus signs. Be patient to write them down. So, and then I go to x1 minus x2. x1 is minus 5. x2 is minus 3. And then try to simplify this. So what happens in the numerator, it becomes positive 3. In the denominator, it becomes negative 2. And then finally, my k value, which was not known in the beginning, now I know it. It is minus 3 over 2. And always you have to keep the exact values. You are not allowed to, of course in this case if you write minus 1.5, that's also okay because that's exact value. Okay, but then, now the problem here is reduced to the previous problem. Because now I have the k value. But instead of 1 point here, I have 2 points. Yesterday we did the calculations explicitly and we realized that it doesn't matter at the end which point I use. Yes? So I don't know. If the numbers of one of them is so big, I prefer the other one. But these numbers are actually, all of them are friendly. So it doesn't matter which one I want to choose. So I use the 1 point formula again. Okay? So here, let us work with A. Then it means that what is x naught, don't get confused, you know. I have given this a name x1 and y1. And I now want to ask you what is x naught and y naught. They are the x and y coordinates of the same point. So don't get confused. You see, for using this formula, I myself gave them these numbers. Yes, but now I want to use this formula. If someone asks you what is x naught and y naught, you will tell that x naught and y naught are coordinates of any point on the line. It doesn't matter which point. So here, if I ask you in this problem what is x naught, hopefully you agree with me, that is minus 5 again. And if I ask you what is y naught, that is 2. And then we also know k. Yes? So then I have my formula. So y minus y naught is equal to minus 3 over 2 x minus 5. And then we have to simplify that. So this becomes y minus 2 is minus 3 over 2, and then I have x plus 5. And I told you that usually you shouldn't stop here. Try to simplify it as much as possible. So what I do, I multiply minus 3 over 2 in, so it becomes minus 3 over 2x, minus 15 over 2. Then I move 2 to the other side. It becomes positive 2. And I hope that you can do this calculation in your head. What is the answer? It's minus 3 over 2 times x. What is that number? Then you should calculate this in your head. Minus 15 over 2 plus 2.
19.
No.
19.
One of them is positive, the other one is negative. So you go to scratch paper, minus 15 over 2 plus, instead of 2 you write 4 over 2. So it becomes minus 11 over 2. And that is the answer that I provide for this one. Okay, let me ask you one question here to test your understanding. Do you think that this point is also on this line or not? It has to be. That's a very good phrase. It has to be, because otherwise I have problems. Because I started to solve this problem. I want to find an equation for the line that passes through these 2 points. So it means that these 2 points should lie on this line. Yes? Okay. If you have access to Geogebra, you can immediately more or less confirm that. How? By finding this point in Geogebra and asking Geogebra to draw this line. And then you see that this point will be on this line. But if you do not have access to Geogebra, how can you confirm? This is an important question. Pay attention. If you want to confirm that this point lies on this line algebraically without drawing it using Geogebra, how can you confirm that? Yes?
You can just change x to the x value given and the y to the y value and see if the equation is correct.
That's the best way of expressing it, yes. So it means that this is very important. A point lies on a line if and only if when I replace x with the x, when I replace y with the y, this equality turns out to be a true equality. It's extremely important to remember this. So let us check. This is not the part of the solution. Let me check it in a scratch paper. I replace y with -1. I ask my question mark here. Is it true that this is the same number if I replace x with -3? Yeah, it seems. Let us see if it works or not. We should be able to confirm that. If this is not the case, I have done something wrong in my calculations. Okay, let us confirm that. The left-hand side, I don't need to simplify anything. It's -1. Let me simplify this part. This one multiplied by that one is positive 9 over 2. And this is already minus 11 over 2. But 9 over 2 minus 11 over 2 is minus 2 over 2, which is exactly minus 1. So it means that this confirms that this point is indeed on this line. Remember this fact. A point is on a line if and only if when you replace x with the x coordinate, you replace y with the y coordinate, the equality turns out to be true. That's an important fact to remember. Okay, I intentionally wrote you two more here because I want to draw your attention to some point here. That is the same problem. Yes? You see, I have changed the numbers only. So why do you think I have done that? Can you think and answer part 2? For example, for part 2, you can immediately answer me without even doing one single calculation. For part 3, you can do the same thing. That is, I want to draw your attention to it. So part 2. Yes?
Is it because it's the second one is a horizontal line, and the second one and the third one is a vertical line.
Exactly. So you really don't need to calculate. So you see the y coordinates are the same here. So if you want to visualize that, so what is happening here? The point 1 and 3, so this is 1, 1, 2, 3. This is point A. This is my point A. What is my point B? 5 and 3. Yes? 5 and 3. So 1, 2, 3, 4, and 5. But the height is again 3. So this is my point A. This is my point B. I am interested in a line that passes through these points of the same height. So this line definitely becomes a horizontal line. Yes? And if I have this horizontal line, it means that this is y equals to what? Every point on this line has one property in common. We don't know the x values of different points. They can be any number that you like. But the height, the y value should be exactly 3. So just by imagining that, you can immediately answer this. An equation for this line is y equals to 3. Of course, be careful. In this case, if you don't realize this and you do the same thing, you will be able to solve it. Why? Because if you want to find the k value, if you didn't know about this, no problem, no serious problem will happen. Why? Because you write x is equal to y1 minus y2 divided by x minus x2. But the numerator becomes 0 and the denominator becomes minus 4 and the answer becomes 0. And then what you do, you can use 1 point formula. But in this case, it becomes y node will be 3, but the k value is 0 multiplied by x minus x node. But 0 multiplied by everything is just 0. And I told you, you move it to the other side. So you see, there is no problem happening here. If you don't realize that that's a horizontal line, you will be able to get it from the formula. But for the third one, if you do not realize that this is a vertical line, you will be in trouble. Yes? Why is that? Because if you want to solve the problem using the formula, the k value becomes the x coordinate, y coordinate minus the y coordinate, but the x coordinate minus x coordinate. Then it becomes 9 over 0. Then you realize something is going wrong, it is undefined. At this step, you realize that, okay, this should be a vertical line, because only vertical lines, the slope of vertical lines are not defined. But if you realize that these two numbers are the same, you really don't need to do any calculations. You realize that this line should be vertical, I write this equation, finished. Here I realize that this should be a horizontal line, I write this equation, finished. And if none of these cases happen, this would be the solution. Yes, I want to have this in the back of your head when you want to do the calculations quickly. Any questions here? Okay. Now let us think a little bit about the form of the line. That is extremely important. So now we want to make it a little bit similar to what you have studied before. Yes? Okay, so if you remember, we had this formula for my equation. Y minus y node is equal to k x minus x node. Okay, but now let us do some algebra. Y minus y node is equal to, I multiply k in, it becomes kx minus kx node. Yes? And then I move y node to the other side. So it becomes y equals to kx plus y node minus kx node. That would be the form of my equation after this algebra calculations. But now look at the form of this equation. If I ask you what is y node, k, and x, you will tell me that x node and y node and k are constant numbers. So if I give you the x node, y node, and k, in principle you can calculate that and it becomes a constant number. And it is common to call this constant number m. Yes? And then you see that the equation is of this form, kx plus m. Okay? So this is an equation of a straight line whose k value is this number k. Yes? Whose slope is k. So you see that probably you have already seen this form of the equation of a line, but I want you to understand that is exactly what we have here, written in a little bit different form. But this is not true. That so you see that by starting changing k and m values, what will happen? Yes. For example, let us fix m. Let us keep it 0. Okay. Let's choose m to be 0. Then I will get this, and I have one parameter k to start changing it. What do you think will happen if I start changing the value for k? First of all, let me ask you one question. We don't know k, but are you sure that all these lines, why I am saying all these lines? Because when I choose a value for k, I will have one equation. One equation means one line. If I change my value for k, I will have another equation, so it represents another line. So if I ask you how many lines are represented by this equation, what do you say? How many lines are represented by this equation? Infinitely many, one for each choice of k. Yes? Is that right? And then if I ask you, how are they related? So if I have this line, so assume that here is the origin. If I start changing this value of k, what will happen for this line? Yeah, it will start rotating, yes? Because I told you that the k value is equal to the tangent of the angle that my line makes with the x direction. So if I change k, it means I will change the angle. Yes? So if I change the angle, the line will start rotating about the origin. Yes? Okay. This will represent all the lines except one single line. What that line is? You see, if I change k, the line will start rotating. it will cover all this. Does this formula cover this horizontal one? Yes. If I choose k equals to 0. I don't know. If I increase k, this will start rotating in that direction. Or if I choose k to be negative, it will increase. It will rotate in that direction. Yes, because the slope should be negative. So, but there is one line, and that is exactly this vertical line. This vertical line cannot be specified using this equation. This equation specifies all these lines except the vertical line passing through it. Yes, so that is I want you to know. But let me do it the other way around. This time, let me keep k a fixed number. So let me give k equals to 1. And then I would write y equals to, instead of k I put 1. And then I change m this time. What do you think will happen? Because here, if I ask you what is the slope is 1 and fixed. So it means that the angle is fixed. But when I start changing m, what will happen? Okay, let us understand what is the meaning of m. This m, by the way, has a name. It is called Y-Intercept. So we want to understand, we understood what is the role of k, what is the role of a slope. By changing the slope, I will change the angle with the positive x direction. But what will happen if I start changing m? Let us understand what is the meaning of m. My claim is that independent of my choice for k, let me ask you this question. Can you tell me where this line intersects the y-axis? Yes? So here, my question is that I have this coordinate system x and y. I ask you to draw the line for this, for a given value k and n. This line might intersect the y-axis at some point. I want you to find the coordinates of that one. Let me make the question simpler. If I ask you this line, draw this line, for example, and then this line will intersect the x-axis at some point and the y-axis at some point. I want you to find the coordinates of those points. How do you do that? For example, in this case, I know that if you draw it, the graph would be something like this. Something like this, okay? Now this point has two coordinates, x and y. This point has two coordinates, x and y. Yes? I want to answer all these 4 question marks by looking at the equation of this line. So how can I do that? Let me ask you and then you answer. From these 2 question marks, one is immediately clear. Which one is that and why?
The x.
The x is 0. Yes? Why? Because you see by your eyes that this point is on the y-axis. So it means that the x coordinate of this is definitely 0. And now from these 2 question marks, again one of them is simple to answer. Y is 0 because you are on the x-axis. So this one is also clear. Now, to answer this question mark and answering this question mark, I have to use this piece of information. This is the line. Assume that you have drawn this line and this is one. Now I want you to answer this question mark and I want you to answer this question mark. Anyone else? How can I answer that one? Let us concentrate only here. What is this question mark? What is the value of that question mark?
Why?
Yes, Tim?
1.
It should be 1. Yeah, the answer is correct, but can you motivate that?
Yes, because since the slope is 1,
Yes?
it will, for each base it moves an x, it goes up 1. Because we have plus 1.
I understand. That is a correct answer. Thank you. But my point was not that answer. I want to answer it in a different way. That's completely correct. But if the slope is not that friendly, you cannot use that method. For example, if I give you a very bad number, bad looking number, if I give you this equation, because this number is so bad, your method, even though in principle correct, might be it's not easy to guess what will happen, yes? You understand what I mean?
Yes.
Okay? So, there is an alternative way. Now we can answer.
Well, I mean, M is where Y intersects.
But why? I want you to feel out. Yes, you are right. This number that you see here is always this number. So here, if I ask you what is this question mark for this very bad form of line, you really don't care about this mess here. The answer is simply 5. Yes? So this question mark, and that's what I want you to tell. This question mark is exactly this M. But I want you to understand why this is always the case. You really don't need to worry about. Whatever you see here, that number is the answer to this question mark. And this is why it is called Y-Intercept. Because that would be the point of intersection of your line with the Y coordinate, with the Y axis. So why is that true? This method I want you to learn. These are very simple things, by the way, but based on my experience, I realize that students doesn't quite appreciate these simple facts. This is why I'm emphasizing on it so much. Okay, so what I want to do, I would say that, okay, I don't know this question mark, so question mark is not something good. Let me just write it, for example, A. And then I want to find A. Yes? But now, this point lies on the line. You need to remind one thing for yourself. If you know that a point is on the line, it means that if I replace Y with the Y coordinate, and if I replace X with the X coordinate, that equality should hold. Yes? So I know that this point is on this line. Yes? So it means that if I replace Y with A, which I don't know yet, and if I replace X with the X value, then this should hold. And then it gives you immediately that A is equal to what? A. And that is your answer. Okay? Now, this point is called the X-Intercept. And now can you answer this question mark using the same trick? You would say that, okay, this question mark I don't know, so let me call it B. But I see with my eyes that this point is on this line. Again, I can use the same strategy. So it means that I go to the equation of the line, replace the Y value with the Y value, replace the X value, X coordinate with the X with the X coordinate, and then plus 1. This should hold. If someone asks you why this equality should be there, because you say that this point is on the line. And then what is only question here for me is B. I move it to the other side, so this becomes minus 1. Okay? Of course, I want you to understand, but the rule of thumb is simple. Whenever you want to find the Y-intercept, you put X equal to 0. Whenever you want to find the X-intercept, you put Y equal to 0. But I want you to understand, you see here, look here, compare this one with that one. This is Y-intercept, I put X equal to 0. Look here and here. I wanted to find X-intercept, I put Y equal to 0. So this is a rule of thumb, you can immediately do that, but I want you to understand, not just memorize that. Okay? So and then, let me try to ask you this question. I give you this line, kx plus m, and I ask you to find the Y-intercept. The Y-intercept is a point. When I ask you to find the Y-intercept, you need to give me a point. So what is the x-coordinate of the Y-intercept? It's always 0. But this one I need to find. So let me call it A. Yes? This should be on this line. So it means that if I replace Y with A, and if I replace X with 0, this should hold. Yes? And then this is cancelled. the A that I was looking for is nothing except M. So this is always the case. So if I have y equals to kx plus m, if I ask you what is the y-intercept, immediately you can answer 0 and this number, whatever it is. And now I ask you the same question. What is the x-intercept for this line? What is the x-intercept? You need to think in this way. Babak is asking about the x-intercept. I have to provide two numbers for him. One for the x-coordinate, one for the y-coordinate. X-intercept. The y-coordinate is 0. But this is question mark. Let me call it B and try to answer this question mark. What should I do? This point should be on this line. I replace y with the y value. I replace x with the x value. Don't get confused. I am looking for what? There are how many unknowns in this equation apparently? K, B, and M. But which one is my subject now? My subject is B. So I assume that everything else is no. So I have to make my subject alone. So I move M to the other side. Minus M is KB. And then I want to make B alone. So I divide by K. So this becomes M over K equals to what? B. And then, so this is why people doesn't talk about y-x-intercept, because the formula is a little bit complicated, yes? So this, what I want, this is the y-intercept. And if I ask you the x-intercept, what you have to do, you can write 0 here, and instead of B, you can put that one here. This I don't expect you to have it in your memory, but this I expect you to have. Yes, if I immediately ask you what is the y-intercept, just refer to this number. Okay? And don't get confused. So let me ask you. I give you y equals to 2x minus 5 over 3. If I ask you what is the y-intercept of that, you should be able to answer it immediately. When I say y-intercept, I mean a point. So it is 0 and minus 5 over 3. But if I give you this equation, 5y equals to 2x minus 3. What is the y-intercept of this line? What is the y-intercept of this line? If you answer minus 3, that is wrong. Because this formula that we discovered is for this form. And by the way, in the book, this is called the K form. This formula is called the K form of the equation of a line. So is this the K form? The K form needs this coefficient to be 1. If that is not 1, it is still not the K form. So you have to reduce it to the K form yourself. Yes.
Is the answer minus 3 divided by 5?
5. So you have to make this one 1. So you divide by 5 first. This becomes 2/5 x minus 3 over 5. Now it is in the K form. Now it is in the K form, so I can use my memory and say that minus 3 over 5 is the y-intercept. Let me ask you, what is the x-intercept of this line? What is the x-intercept of the same line here? Yes?
3 over 5 divided by 2 over 5x.
That's 3 over 2.
No, I just want to ask you the y in x-intercept.
3 over 2.
Use the rule of thumb. Do you remember what was the rule of thumb? If I want to find the y-intercept, I put x equal to 0. If I want to find the x-intercept, I put y equals to 0. Yes? And that's the rule of thumb. You could do it here. So I put what? I put y equals to 0. This vanishes. So 0 becomes 2x minus 3. And I calculate x. It becomes 3 over 2. So then the x-intercept would be 3 over 2 and 0. Yes? So remember that. I don't want you to memorize that, but that is up to you. So if you want to find these intercepts, you should be quick. Okay? If you want to find y-intercept, put x equal to 0 and solve the equation. If you want to do it the other way around, put the other variable equal to 0 and solve the equation. Okay.
Oh, I used to.
But So this I want you, and now I want to ask you this question. Do you remember I started from the effect of k? We realized how changing k will affect my line. By changing k, my line, changing k, but keeping m fixed, my line will start rotating. Now we can immediately understand what will happen if I keep k fixed and I start changing m.
Y-intercept will change.
Will change. So it means that the k value will not change. So it means that my angle will not change. So I am not able to rotate, because if I start rotating, my angle will change. So I have to keep the same angle, but if I increase m, this y-intercept goes up, and if I decrease this, it will go down. So it will actually be translated upward or downward, depending on am I increasing this or decreasing this. So remember these two effects for a line. Changing k will change the orientation or inclination, and changing m just takes up and down. Yes? Is that clear? So this is important to understand. Okay. Now, so I want, there is another form of the line in the book, and I want to talk about that. So if I ask you what is the weakness of 1 point or formula, you see that, is there any big difference between k form and 1 point? You see they are the same. What I did, I changed the form of this by doing some algebra and giving this a name. Yes? So k form is in principle the same as 1 point. There are no difference. But what is the weakness of k form? So let me, for example, how should I ask you this question? Okay, so for example, if I choose k equals to 0, m equals to 5, then the k form will give you y equals to 5. It's a horizontal line. Yes? If I choose k equals to 2 and m equals to 0, for example, it gives me what? 2x plus 0. It gives me this one. If you draw this line, it would be something like this. This one, if you draw that, it would be something like that. Yes? I don't know, if I choose k equals to -1 and m equals to 1, then what is the equation? The equation would be -1 times x, which is -x plus 1. And I don't know, if you draw that one, it would be a line like this. Okay? So it seems that by choosing different values for k and m, I am generating different lines. Yes? It is true, but it doesn't matter how should I change that, I will not be able to generate one particular type of lines. That is the weakness of this one k4 formula. So you see, if you start changing k and m, you will start generating a lot of lines, infinitely many lines. But no matter what values you choose for k and m, you will not be able to generate one particular type of lines. What are those lines?
Non-straight lines.
Yes?
You can't generate second degree lines.
No, there are no second degree lines. What do you mean by second degree lines?
Line with an exponent of it.
Okay, they are not lines, but that is what I told you. You see, I always, so technically you are right. This is also a line, but that's a curved line. In this chapter I told you, I always, when I say line, I mean a straight lines. So that is not the weakness of that. Yes, you are right, of course. If I'm just talking about the straight line. But even for the straight line, this is not complete. It will generate all these sort of lines except vertical lines. There is no way for this equation to generate a vertical line. Because what is the vertical line? A vertical line is of this form. X equals to a number 5, for example. Can I generate this equation by fine-tuning the values of k and m? No, it is not possible, you see, because this value is always there, and for a vertical line I have to get rid of y, but there is no way to get rid of y here. So this will generate all possible lines except vertical lines. Is that understandable? So if I ask you this formula, do you think this formula will generate this? Do you think that formula can generate this equation? Can you tell me which value for k and which value for m I should choose so that this generates this? So you need to change the form of this to the k form, yes? So I want to make y alone if possible, because y is alone in the k form. So I keep 5y here, and then what I do, I move it to the other side, minus 2x, I move this one to the other side, and then I divide by 5, so it becomes minus 2 over 5x plus 3 over 5. Now can you tell me what are k and m values? It is very simple. The k value is how much? Minus 2 over 5, and the m value is 3 over 5. So it means that if I choose k to be this number, and if I choose m to be this number, and put them in this equation will generate this equation for me. Yes? But this equation is not capable of generating vertical lines. So this is why we have another form of the equation for a line. What is that? This is called the general form. So the general form. And the general form is like this. A number multiplied by x, a number multiplied by y, plus another number equals to 0. This you need to have in mind. This is the most general equation that generates all possible lines. Yes? For example, if I want this to generate this, it is extremely simple. I just choose A to be 2, I choose B to be 5, I choose C to be minus 3. But can you tell me how can I generate x equals to 5 using this? This is a vertical. The k form is not capable of generating a vertical line. But the general form is. I need to choose A, B, and C appropriately so that this formula in algebra generates this formula in algebra. Yes?
B is 0.
So B is 0 because there is no y coefficient. What is A then?
1.
A is 1. What is C then?
4.
No.
0.
Minus
No.
6.
So you need to write it in this way because in the general form I have 0 here. So I have to move it here and then compare it with that one. The coefficient of x should match the coefficient of x, so A is 1. What is B then? 0 because there is no y here. What is C then? Minus 5. Yes? So you see that so x equals to 5 is not, it's not possible to generate x equal to 5 using this, but it is possible to generate x equals to 5 using this. So this way of writing an equation for a line is called the general form. It generates all possible lines. So if you know that you are not working with vertical lines, you are on the safe side. You can work with the k form. But if you don't know if the answer is supposed to be a vertical line or not non-vertical lines, it means that you have to use the general form. Yes or no? Understandable?
No, but what was the C in the formula? Is it the C?
It's a number.
It's a number.
So A, B, and C are numbers. A and B cannot simultaneously be equal to 0. And then A, B, and C are constant numbers. So it means that whenever you see an equation in algebra in this form, if you go to analytic geometry and draw the graph of that, it becomes a line. Is that understandable? So because you saw, I told you that in analytic geometry, we are using algebra for geometry.
So with this formula, you have to have the numbers, right?
Yes, again, yes. Yeah.
And this is this can be used for any line.
Any line.
Is there any point in what's the benefits of either of them?
Yeah, I told you. For example, if I ask you find a line with a given property, yes. If you say that okay, that line should be of this form, you need to be there is a loophole here, because you don't know the answer at the end. Might be the answer to that problem turns out to be a vertical line. Yes. If you start with this equation, you will not be able to find that line.
No, but why would you use the K form instead of this?
It's easier to work with.
No.
Yes. For example, that's a good question. If I ask you what is the slope of this line, it is not immediate to answer. Of course, it's a very simple algebra. You can do it in your head. Yes. But if I write this one equals to 5x minus 3, if I ask you what is the k value, you don't think 5. What is the y-intercept minus 3? But if I ask you the same questions here, you have to do some algebra. If you want to answer the k value, by the way, what is the k value here?
Minus 2.
So you have to make y alone. Yes, you have a little bit of trouble. Yes. So it becomes y, you move it the other side, it becomes minus 2x plus 3, but then you have to divide by 5, so then you have to do this simple algebra, then the k value is this number, and the y-intercept is this number. Yes? So this is very common, because if you know that the line that you are working with is not a vertical line, I myself prefer to start with this one. By the way, there is a big name for that. This one is called explicit function. Explicit function means that you have y alone on one side and everything related to x to the other side. That tells you that you are expressing y explicitly in terms of x. But this way of writing is called implicit function. So this means that even though y is related to x, but this is a mixture of x and y in one side, y is implicitly expressed as x, but not explicitly. Yeah, this is good to know. And the reason that this has become so popular is because functions, when you deal with functions, you always have y on the left and everything related to x on the right. So this means that a vertical line is not a function at all. Do you remember I told you that what is the point, what is the important point of a function? So do you remember, if I have this situation, then what was a function? I had two sets, I want to assign points together. Yes, from one set to the other set. But I am not allowed to assign 1 point to 2 points. If this happens, this is not a function. Yes? So the vertical lines are not functions. Yes, because I am assigning, you see, so I am assigning the same value for different, let me see. So here I have, for example, if this is 3, I have 3 and 1. Here I have 3 and, for example, 2. So it means that 3 is assigned to 1, simultaneously 3 assigned to 2 as well. So it means that if I write 3 here, 3 is assigned to a lot of points. So that's not a function. So that is the reason that we usually write it in this form. But when we want to work with geometry, we don't care about functions, we care about geometry itself, and that is a reality that vertical lines are one possibility for us. Yes? If we write them, we are intentionally excluding them from being taken care of. And if my answer turns out to be a vertical line, and I start from this one, I will never be able to get that answer, because this doesn't care about, it's not sensitive to vertical lines. Yes? That's the difference. Yes?
Another thing, isn't it always clear if a line is vertical or not? Like when you work with a line, like if you have...
No, think in this way. For example, in the future, I give you a curve, and I ask you to find an equation for the tangent line. So you cannot guess that a line is supposed to be a vertical line or it's supposed to be an inclined line. You have to do the calculations, and the answer, whatever it is, it pops out from the calculations. So you cannot see a priori what is going to happen. You understand what I mean? Yeah. Okay, so now we have 3 forms actually, so let us write them here. 1 point formula, which is extremely important, and then we have the K form, more or less they are the same, and then we have the general form. Yes.
How do you use the general? How is it used?
No, how do you use it? I will tell you. So for example, you need to know that whenever you have this equation, it represents a line. Yes, for example, you shouldn't get confused. I will write, let D be a line. Let me write L for line. Let L be a line of with equation 5x minus 3y equals to 7. So you shouldn't get confused what Babak is saying. This is a line. Why? Because you compare it with the general form, you see that A is 5, B is minus 3, C is minus 7. So any equation which can be expressed in this form, if you go and draw it, it becomes a line. That's what I want you to know.
So with this you can make it so you get the y along the kx value, the k value.
Yes, yes. And you need to know that. If I ask you what are the k values and n values, you have to change the form of this general one to the k form and read k and m. So whenever you want to read the k and m, you have to write it in the form of this one. Yes? And then the coefficients you read. Yes? Okay. So let me give you a little bit of break because I want to continue with some examples and then we end the lesson. Okay? So I will give you a little 5 minutes break and then I will come back. Okay. So example. Yeah, please pay attention to these examples. They are important. So this question shouldn't be strange for you now. Show that the point A with coordinates 3 and minus 2 lies on the line 2/3 x minus 3y equals to 8. You see, this question shouldn't be surprising for you here. A point is in 2 numbers, x and y coordinates, but do you agree that this is a line now?
Yes.
Because you can compare it in your head with the general form. So whenever you have an equation which can be expressed using that general form, there is no doubt that's a straight line. Yes? And I'm asking you, show that this point lies on this line. I don't mean go and draw this and force me to believe that this is on the line. You have to do some algebra to show me that this is the case. So tell me what to do. Everyone, you don't need to do it yourself, I can do it here for you, but you tell me what to do.
We need to make this equation to the k form.
No, you don't have to. No. Don't do algebra which is not necessary. Tell me, I told you this is an extremely important point, not for this lesson, for the future. If a point lies on a line, if and only if what happens?
If you replace the x.
Exactly, that is the only thing. If I replace x with x and y with y, this equality should be a true equality. If that is the case, that is end of the problem. It's confirmed. Otherwise, it is not there. So what I should do, I would say that I would replace x with the x coordinate, I will replace y with the y coordinate and ask myself, is it true that this becomes 8 or not? If the answer to this is positive, then it confirms that the point lies on this line. If it is negative, it means that that point is not on the line. Okay, that is the only way to check if a point is on a line or not. Yes or no? Clear? Okay, so let us check. Do you think it is true or false? 3 and 3 are cancelled, so it becomes 2. Minus 2 times minus 3 is 6. Question mark 8. True or false? True. So that is the end of the problem. This is a simple thing. Remember that when I ask you, is this point lies on the line? Yes or no? You should be able to answer it using this. Okay? We can make it a little bit harder. By the way, if I ask you, I haven't asked you in this problem, but if I ask you what is the k-value of this line, can you find the k-value? This is not part of the lesson, so let me write it in a box. That's not part of this question. It's part of the lesson, sorry, but it's not part of this question. So what is the k-value? What is the slope of this line?
It's 2/3 divided by 3, which is...
So you have to make it right. You see, if I want to answer the k-value, I don't like fractions, so I get rid of them as soon as possible. Yeah? So I get rid of this 3 by multiplying everything by 3. So this becomes 2x, and then it becomes minus 9y. It becomes how much? 24. And my goal is to make y alone. So I move this one to the other side. It becomes 24. Let me write it in this way. Minus 2x plus 24. It doesn't matter. And then I divide by minus 9 because I want to make y alone. So it becomes 2 over 9, positive. But that one becomes minus 24 over 9. So what is the k-value? 2 over 9. So that is the slope. I can also ask you this question. What is the angle between the line and the x-axis? I can be careful. I can design a lot of questions using them. I can give you one question like this. I can give you and ask you what is the k-value. I can give you this line and I can ask you what is the angle that the line makes with the x-axis, positive x-axis. So what you are supposed to do,
I think we should use inverse.
exactly. So that value is tangent of that angle. Yes? And this is supposed to be 2 over 9. So you take your calculator, use the tangent inverse button on that, and you get your angle. So you see, you should know all these concepts. I can ask you a diversity of questions, and you should be able to answer them.
So you will mix trigonometry.
Yeah, that's possible. That's the whole point. Okay, let me change the question. This question is also a good question. The idea is the same, but I can design it a little bit differently. So this is that question. Determine A such that the line A minus 2x minus 3y equals to 2a minus 4 passes through the point A with coordinates minus 1 and minus 2. That is a little bit, the idea of this question and the idea of these questions are exactly the same, but I have changed the form of the question. The point. There's a T missing. Okay, first of all, tell me, do you expect that this equation, even though a little bit complicated, is an equation for a line?
Yes.
Why? So that equation is a little bit strange because you have an extra variable in. Because in equation of a line, you expect for x and y. But in that problem, on top of x and y, you also have another parameter, which is a in this problem. So, if I ask you, is this one line or infinitely many lines? I hope that you agree with me. This is an equation for infinitely many lines. What? One for each choice of a. If I give you a equals to 7, you put 7 here, it becomes an equation of x and y, which is one line. If I change my idea from 7 to another number, it becomes another line. So this is a bunch, it is infinitely many lines. Okay? And I want to fine-tune them in a way that it passes through -1 and -2. Yes? Okay, let me compare this one. Write it here for you. And let me compare this equation with the general form. Okay, can you tell me what is in this equation, what is playing the role of this A? Can you tell me?
A minus 2.
A minus 2. What is playing the role of B?
3. Minus 3.
Minus 3. You need to keep that. What is playing the role of C?
2A minus 4.
No, minus 2A plus 4, because you have to move it to the left and then make it 0. So, but don't worry about that. But I want you to understand, even though it is a little bit complicated, but you understand that this is in principle a line, because its equation is of this form. Now, how can I solve that problem? How can I solve that problem?
By replacing X and Y.
Exactly, that's the same story. You see, you don't need to be worried about algebraic complications. That is the same problem. This is a line, whatever it is, I don't know, and I really don't need to spend time to make it right. That is one line, and that is one point. My goal is to make it somehow that this line passes through this point. It means that the line should lie on this line. And there is one way to do that. The coordinates should satisfy the equation. What does it mean? It means that I go to my equation, replace x with x coordinate, replace y with y coordinate. This should hold. Yes? And then if I ask you what is the unknown here for you, the unknown here is A, and what is demanded in the problem? Exactly A. That is the problem. So you know the idea of these two problems are exactly the same, but expressed in a different way. Okay, so what I do, I multiply -1 in, it becomes negative A, positive 2. This becomes positive 6, it becomes 2A minus 4. And then what happens? I will have minus A plus 8 is 2A minus 4. I move 2A to the left, I move A to the right. This becomes minus 3A minus 12, and A becomes 4.
So the answer is 4.
Yes, here what is demanded? Determine A. So the answer, A is 4. Yes? I think that is a good idea. If I can demonstrate it here by Geogebra, this one, you get a better feeling for that. Okay, so because Geogebra is going to be on this screen, I have to clean some of them so that you can see it. Let me see, because I think it's good. It's very good to see the demonstration on Geogebra. What is exactly going on? I hope that I can do it. So let me clean all these lines, and then I will keep this. I will write this here because A minus 2 x minus 3y is equal to 2A minus 4, and the point was what point? Minus 1 minus 2, and then we calculated and we learned that A should be 4. Yes? So let me try to demonstrate this using Geogebra. So let me pause this and then continue recording. Okay. So what I do here, I will type that equation in Geogebra. Of course, Geogebra will start complaining that I cannot draw that, and that is clear because Geogebra doesn't know A yet. But let me see if it is going to work exactly what I think. Minus 3y, so minus 3y equals to what? Read it for me, 2A minus 4, yes? As soon as I press enter, yes, it generates a slider for me. Because it tells you that what value for A do you want to do. And let me also introduce my point A. My point A, what are the coordinates? Can you tell me what are the coordinates? Minus 1 and
Minus 2.
minus 2, yes? So that is also my point here. Yes? You see, this is a slider. What is the value for A right now? It's 1. And you see that the line generated by that formula is not passing through A. You see that, yes? So here you see if I start changing this, do you expect that, by the way, this should rotate? Did you expect before that when I change A, it should rotate? You see, it's very nice. It is rotating about the point, the X-intercept. Yes, let us understand, by the way, this one. Why do you think? Could you expect, before seeing it in Geogebra, that point, you see this point here? This point remains fixed. Could you anticipate that before seeing it?
Yes, because it determines the.
So how?
In the equation is A minus 2 times X.
No, this I told you, this point is called the X-intercept. What was the rule of thumb for finding the X-intercept?
What? Make y 0.
To make y equals to 0. When I put y equal to 0, then this 2a minus 4, if I factor a 2 out, it becomes 2 times a minus 2, but a minus 2 and a minus 2 will be cancelled, so x becomes 2. Independent of the value that I choose for a, this is always the case too. Okay? Okay, but for the time being, let me just increase the value now. According to our calculation, when a becomes exactly 4, this line should pass through the point A. Yes? Let us check that if I can do it. By starting increasing this, you see, the line is changing. And when I get closer to 5, at 4, it should match with the point. But I don't know if I can do it with my hands. Yes, and it passes. Yes? So that is the idea. So do you remember, if I ask you this formula, how many lines this formula represent? Infinitely many. By changing A, all those lines are covered. But only one of them will pass through the point, and before seeing this demonstration, we were able to calculate it exactly. And that value is actually confirmed by Geogebra. So is that understandable? Yes or no? Okay. So this I wanted you to understand when we solve this problem, in principle, what we are doing. It is very important to have this connection, otherwise it is completely waste of time. Okay, thank you. So we stop here.
Thank you so much.